Okay, so how is everyone today? Good? All right. So I posted the course notes for Monday. I put them on Box. And I also posted video and posted that to YouTube and sent messages about it. Any questions about that? Just the notes and stuff? The first online homework 0 has been posted. That corresponds to lecture 0. Today's lecture 1, so there'll be an online homework 1 posted. The written homework, the first group of written homework is due on Monday, 5 days from now. And on that same Monday, we'll have a quiz. Okay, so any questions about the schedule? All right. So today's the 22nd. And now we're in section 1.2, which is called something like exponents. Okay. So to get started, we're going to talk about multiplication. Multiplication. All right. So start out by saying this. Let n, little n, be in the naturals, and x in the reals. So let's remember what that means. So what are the naturals? Almost. So the no, not quite. Positive integers was close, but the answer is actually the non-negative integers. Now you might you might say like, wait a minute, is there a difference? And the answer is yes. So what is the difference between positive and non-negative? Well, 0. I heard someone say 0, right? So 0 is a natural. So you know, as fate would have it, mathematicians are like the lawyers of the science people, you know. So like we really like care about positive versus non-negative. All right. So n is a natural and x is real. That means that x is any old number on the number line. Okay. So what we're going to do is we're going to pretend that we don't know what multiplication is, but we do know what addition is. And so now we're going with the fiction that you're seeing this 2 multiply x for the first time. Okay, and we want to know how are we going to do this? Well, the way we're going to do it is because it's 2 multiply x, we're going to take 2 copies of x. So we've got 2 x's there, and what we're going to do is we're going to combine them with the only thing we know how to do, with addition. So now, that's the definition of 2 times x. So what do you think the definition of 3 multiply x should be? Right, so now we're going to make 3 copies of x, and we're going to combine them with addition, the only thing we know how to do. Okay, and I think you can imagine, you know, I could just keep going down the page. Okay, so then I'll leave it there, but that's not where the interest is. Rather, I'm going to go up. So specifically, what we're considering is we're going to consider the definition of n multiplied by x, like that. So 2 is a natural, 3 is a natural. What is the next smaller natural? 1, right? So now 1 times x. Now let's try and say it out loud, because I want you to sort of sense the clumsiness of the statement. 2 times x means make 2 copies of x and add them all together with you know, and combine them with add. 3 times x means make 3 copies of x and combine them together with add. 1 times x means make 1x, make 1 copy of x and then combine them all with add. It's kind of a weird statement. But now here's the problem. What's the least natural? 0. Okay, so 0 multiply x. So if we continue in this vein and with this idea, you know, oh, oops, I wanted to write an x here. So I made that 1 copy of x. So that goes with that one. So for 0 times x, I suppose that means that we should make 0 copies of x and then add them all together? It's not clear, right? That's kind of what I did, except now there's nothing on the right-hand side. So can you see that there's like an issue of like definition? Okay. Well, also observe that, you know, it's my style to make all the stuff line up vertically, you know, and make it all line up nice. But do you observe that the amount of horizontal space on either side of the equals is not the same? That's not my style. So whenever you see something like that, that means I'm going to do something. Okay. So from your previous experience, please tell us, what is 0 times x supposed to be? 0. Okay. So that is in fact the right answer, and in fact all of these have a 0 in front. They all have that. So 3 times x really is that you take a 0 and you take 3 copies of x and you add up all 4 of those things with add. Okay, interesting. So 0 was somehow important. Okay, that means that, you know, generally speaking, n multiply x, well, that'd be 0 and then plus x plus dot 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 plus x. And how many x's did I have to put there? There's n of them there, right? N x's. Okay, well, you know, I could say it like this. For this particular one, for this particular line right here, how many times did x have to be written? 3. You're telling me it had to be written 3 times? Ah, that's why we call it 3 times x, right? That's the reason for that language. X is replicated 3 times, and then you add them. Okay, so what I want you to see from this is that multiplication, at least when you're multiplying by a natural, so multiply by n is repeated addition. Okay, let's do the next one. This is raised to a natural exponent. So raise to an exponent. Okay, so again, I'll say let n be natural. And x in the reals. X in. Did you have a question?
Yeah. What is the little 3 dots by multiplying?
Ah, sorry, yeah. This is pronounced therefore. Therefore. Yeah. I'm not sure about that last E. But what this means is that because of what we said, it is a consequence that multiply by n is repeated addition. So x is a real. And so now we want to define what it is that we mean by x with exponent n, with superscript n. So now what we're doing is that we're going to go with the fiction that you've never even heard of this, but you do know what multiply is. Okay. So x squared. Well, you know, sort of like this one. This one was 2x, like that. And then we've got an x and a 2 there, so I'm going to proceed in kind of the same way and make 2 copies of x. And then I need to combine them, but how am I going to, what am I going to combine them with? Multiply? Why not add? Okay, right, because we did the add here, right? So here, this is make 2 copies of x and combine them with a multiply. That's what x squared means. And similarly, x cubed means make 3 copies of x and combine them all with multiply. Okay, interesting. But again, I think you can imagine I could proceed this way as far as I wanted. It's going the other way that is of interest. So if we write x and then with exponent 1 like that, that means make 1 copy of x and multiply them all together. All right, I did it. But again, we're defining what this is for any natural exponent, n. And we've made it, you know, we've done 1, 2, 3, and you can imagine how it goes proceeding. But what's the least natural? 0. So then the question is, what about x to 0? 1? Wait a second. I thought we said we were going to use 0. So you're telling me that there should be a 1 there? That's crazy talk. Why 1? Okay, I don't dispute that that is, in fact, going to be the case, but the question is why? So the claim is that that there should be a 1 here. Okay, and that's correct. Yes.
Because if it was 0, you'd have to multiply it to each one, and that would just make them all 0.
Okay, so let me write this down. So I'm writing these red ones here, and what you're saying is that if instead of writing red 1s, if I was writing red 0s, then the whole thing would be 0, right? That wouldn't be interesting. Yeah, or right for that matter. But okay, so you're telling me that here, for reasons that aren't clear, we were supposed to use a 0, and here, for reasons that are also not clear, we're supposed to use a 1. Okay, why? Why not a 7? Or whatever. Okay. Well, this is the piece of information that I wanted us to see. Do you see that there's something? Okay, there's something to ask. Yes, you are supposed to use 0 there. Yes, you are supposed to use 1 there. But why? The reason is that notice that what multiplication by a natural is, it's repeated addition. It's repeated addition. And what we every operation, addition included, always not always. As a mathematician, I have to say not always, but basically I'll say always, has an element that performing the operation with this element is the same as doing nothing. So do you observe that you take whatever your favorite number is, a, and then you add 0 to it, what do you have? A. So adding with 0 is the same as doing nothing. As a result, 0 is referred to as the additive identity. So additive identity. What that means is that you take whatever number that you like and you add 0 to it, and you just get that number back. That's the same as doing nothing. That's the reason why it must be this way, is because what this process is this is repeated addition. And what you're asking is that what if I do no additions? Then what's the element that's neutral with respect to addition? 0. That's why it's 0. Okay. So now, raising to an exponent here. Raising to an exponent n is, so by analogy, if multiply by n is repeated addition, then raising to exponent n is what? Repeated multiplication. So to carry out this procedure, we have to multiply repeatedly. So then what if we're saying that, well, in fact, we want to do 0 multiplications? Then we have to start with the element that's neutral with respect to multiplication. What is it? It's 1. So what's the name for, by analogy to calling 0 as the additive identity? Then what's 1? Very good. So 1 is the multiplicative identity. Which is to say, you take whatever your favorite number is, a, multiply by 1, and that's the same as having done nothing for all a. Okay, so then the notion of having an operation, a way to combine two things of the same type and get a third thing of the same type. You can combine two numbers with add and get another number. You can combine two numbers with multiply and get another number. When you have such a combination, we're always going to be seeking out what the identity element is. So later in the course, we're going to talk about a new operation, and there's going to be an identity element, and we're going to have to find it. But generally speaking, if the operation was named banana, then there'd be a banana identity, a bananative identity, right? Additive, multiplicative, etc. Now I have to put an asterisk here because this is there's one more piece to the story, and that is you can't divide by 0. Like 8 divided by 0 is not defined. Okay, not all arithmetic expressions are defined, and division by zeros is such an example. And another one is that 0 to exponent 0 is not defined. However, I could say something like, well, what about 2 to exponent 0? What's that? 1. What about 8 to exponent 0? 1? Okay. What about a really big number like 1314 to exponent 0? 1. Okay. Okay. Any question about this? All right. So so the identity is important. All right. So now, for the rest of the day, more or less, we're going to talk about laws of exponents. Okay, so this is Exponent Law Number 1. Exponent Law. And I'll just write number 1 because we're going to do several of them. So I'll say let x be in the reals. And I need two naturals, so I'll say n and m are in the naturals. So we've got some number, x, and two naturals. And what we want to do is we want to take this x to n multiplied by x to m, and what we want to write is a formula that somehow says a different way to write this. And the way we're going to do it is I'm going to try and convince you of what the correct answer should be by way of example. So for example, how about something like x to 3 multiplied by x to 7? Okay, now remember, basically the way a math class goes is we can only write down the things that we can only use the rules that we've written down previously. So basically all that we have in play is what's on the previous page. So like all the stuff that you already know is like not valid for the sake of consideration right here. Well, let's start out. do we have an alternative way to write x cubed? How? Very good. So I could say, well, you know, concerning that x cubed, that's x times x times x, like that. Okay, and then, well, we've got an alternative way to write x to 7 also, so I'll do that. So this would be x times x times x, like that, and then times x times x times x times x times x times x times x. Wow, okay. So, you know, in that, in the first group, we've got, you know, xxx, 3 of them in there. And then in the next group, we've got 7 of them. Now, what I'd like to do is I'd like to be able to write another line, but without those parentheses. Now, is it permissible to drop those parentheses? Okay, so I'm going to write down what that would be. So that would be xxx like that, and then xxx, xxx, x. So I just rewrote the same thing, but without the parentheses. Okay, but now here's the rub: is that you've got to tell me the reason why that's permitted. What math statute or law or whatever says that that's okay? Okay, so I'm fishing for an A word. Why can you drop the parentheses? It has something to do with the parentheses. It's an A word. That's a D word. Starts with A. I don't dispute that they are alike, but that's not the one. Starts with A, ends with associative. Associative. Oh yeah, okay, that's it. So this is the associative property. And you know, these are things that you're going to have to know by name. So the associative property of multiplication. So associative is not like some random word. It's chosen on purpose. You know, to associate means to make a group. You know, you could have like your friend. You know, and it would be kind of weird, but in principle, you could refer to them as your associate. You know, you could introduce your friend like, "This is my associate," because we're a group. You know, so this is called the associative property. It allows you to both put in parentheses and take them away, like that. Okay. So now concerning this last line, it's just a matter of counting. How many x's are there? There's 10 of them, right? So now, you know, I labored this, you know, a little hard, but I think you could probably speculate now. What's the general formula that you're supposed to do? Yeah, you add the exponents. Okay, because you know, in grade school, whoops, I was just going to copy the thing again. In grade school, you know, you do problems like, you know, if Harry has a bag with 4 apples and Sally has a bag with you know 6 apples, then how many apples do they have altogether? 10 apples. You know, it's not super complicated. That's basically what this is saying. Is that if this is n x's all multiplied together, and that's m x's all multiplied together, then how many x's are all multiplied together? That many, n plus m of them. Good. So the next one. So concerning this, just to address your concern, you might be wondering, wow, am I going to have to do it like this? And the answer is yes. You are going to have to do it like this, and it will be graded, but only on one exercise. Okay? You're going to have to do it, and then from that exercise forward, then you just use this. But there's going to be an exercise where you got to do it like this. All right. Now, I know that's hard to fathom and stomach, but it's going to happen. Next. So exponent law number 2. Let x be in the reals, And again, we need two naturals, n and m. So again, we're going to take some expression, and we want to figure out what's going to be the shortcut rule. But you know, you're going to have to do it the long cut way at least once on an exercise. So specifically, x to n, and then we'll put that in parentheses, and then raise all that to an m. And the question is okay, I'm going to write myself a blank right here that I'm going to fill in, and we want to figure out how can we rewrite this. Okay. By way of example, how about something like this? X to exponent 4, and then all of that to exponent 3. And again, we're only allowed to use what we've already discussed. All right. So let's think of it like this. So whatever it is that I'm covering there, whatever it is I'm obscuring, that 3 exponent, that 3 exponent is saying that we're going to have to make 3 copies of whatever that is and multiply them all together. So if I'm covering up a y, that means we're going to make 3 y's. If I'm covering up a giraffe, you know, 3 giraffes, whatever it is that's in there. Okay? So the first thing I'm going to do is make 3 copies of whatever that is, and it's an x to the 4. Okay, so then it'll be x to 4, and then multiply x to 4, multiply x to 4. Okay, so then we did that. Now, what is x to 4? All right. So then that'll be x times x times x times x in the first group, and then multiplied by x times x times x times x in the second group, and then multiplied by x times x times x times x in the last group. And then we can get rid of the parentheses with what? Associative law. So this will be x, 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 x. Four more of them. And now it's just a matter of counting. You know, now that we've got that all written there. How many x's are there?
12.
There's 12 of them. So evidently, the answer is x to exponent 12. All right. All right. So, does anyone care to speculate? How is it that you do it? Yeah.
You would multiply the x to n times n.
Very good. Now let's make sure that we understand why. So here's a different apples question. You know, suppose Susan has 3 bags of apples, and each one of the bags has 4 apples in it. Then how many apples? Well, 12, right? I know that sounds a little silly, but I want you to be able to connect that very straightforward apple problem with what we're talking about here. This is saying Sally has 3 bags, and each bag has 4 apples in it. So altogether, there are 12 apples, except we're talking about x's, and not bags, but math expressions. So the answer is x with exponent m multiplied by n. Any question about it? Good? Next is we want to be able to deal with is we want integer exponents. And to make that happen, we need to just one little piece of convention. So to now the exponents have been natural numbers, but now we're going to start using integer exponents. So what is the distinction? Negatives, right? Now every natural is an integer, but not every integer is a natural, right? Because, for example, -3 is an integer, but not natural. Okay, so to make this work, we will define the following. We will define well, first I need to say let n be natural and x in the reals. So then x to negative n. So because n is natural, if n's not 0, so for example, if n is 5, this would be something like x to negative 5. So what we're going to do is we're going to define what is what's meant by this, and it is a synonym, a shortcut, if you like, for this. Okay, so those two things are the same. I'm not saying that there's a reason. I'm saying that this is a definition. Okay. Now to understand the distinction, I could ask, we could like walk outside and I could point to a flower and say, "What's that called?" And you might tell me it's called a rose. And then I would say, then I could say, "Why?" Well, okay. There's not really a why. Okay. Except, in the sort of sense that there was evidently a time when the first person saw a rose, when a first person saw a rose for the first time, they had to come up with a name for it. But it doesn't really make any sense to ask why. It's arbitrary in that way. Why is a hamburger called a hamburger? I don't know. This is a definition. Some mathematician walked up to the thing and said, "I define this to be a rose." That's what I'm saying here. As a result, we have the following. This is the next exponent law. So let x be real, and we need x to be not 0, and we want n and m, in fact, both to be in the naturals. So now we want to deal with this. X to n, and then divide by x to m, like that. So previously, we figured out how to multiply those things. Now we're asking how to divide them. And again, I'm going to leave myself a blank. And let's come to the answer by way of an example. So how about x cubed divided by x to 8? Okay. Well, let's we can only do what we know. So as for the numerator, that means x times x times x, and in the denominator, that means x times x times x times x times x times x times x. How many is that? 6, 7, 8. So that's its meaning. Okay, this is a much nicer way to write it, right? So this is its meaning, and this being here, we're working under the assumption that you know what it means to multiply and divide and things like that. So do you observe that some cancellation can occur? All right. So in particular, because because all of these are multiplied and all of these are multiplied, and all of these are dividing all of those, that means that we could cancel those, and we could cancel those, and we could cancel those. Right? Those cancel. So in the same kind of way that 5 divided by 5 cancels. So now it's a sort of a counting argument. Let's consider how many x's are left in the denominator. 5, so I will write them. X times x times x times x times x. And how many x's are left in the numerator? 0 x's. So now I'm going to write something, and it's going to be incorrect. So if you're going to write it, if you're going to copy what I'm about to write, please carefully note that it is not right. So I'm going to write something that too large of a fraction of y'all are going to say next week. So I see that I canceled those x's, so there's no x's left. So it must be 0 over xx, xxx, like that. Because there's 0 x's. right? There's more than one x? Okay, so something's not right here. What, yes?
1 is a multiplicative identity.
Exactly right. Okay, so can you say it real loud so everyone can hear it?
I can't say that word very loud.
It's a tricky
1
one.
because of the multiplicative identity.
Very good. So look at this product. It's XXX, all combined with product. And what we said is that we're going to make a cancellation. But understand that this is a cancellation within a product, right? And we removed all of the factors so that no factors remain. So that what is left is the element that should be neutral with respect to product, which is 1. But what did we write here? We wrote 0 because that's the element that, well, and 0 is the element that's neutral with respect to addition. So in a sense, from a math professor's point of view, this is kind of right in one way because at least the student wrote an identity element, but they wrote the identity element with respect to addition when we were doing multiplication. So do you understand the problem? Okay, so this is wrong. Because it needs to be 1, the identity of multiplication, not the identity of addition. So the correct answer is 1 over x, 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 x. And then, there's a more compact way to write that. We could write that as 1 over x to 5. But then, if it said write this write this in such a way that it's not a fraction, then how can we write it? Very good. X to negative 5. Okay. Now, would anyone care to speculate what the real formula is? N minus m. So again, to make a an apple story or whatever, that would be like to make it not be negative, I could say it like this. Suppose that Bill has 10 apples, and then he, Charlie, takes away 5 apples. How many apples are left? 5. Okay, like that. Good. Yeah.
Regarding showing our work, so we initially write out all of the x's, and then we can you put the other piece?
Yeah.
So if we jump from xxx over x times to the 8, and we jump to 1 over xxxxx. Sorry,
Like that?
Yeah, if we jump from the first step to the third step.
You won't get full credit.
What about the first step to the fourth step?
You got to show all the steps.
Okay. So
Okay.
the third one counts as a step.
Not this one.
No, the third one.
This one?
Third, yeah.
Yeah. I want to
So if we
see.
jump straight to 1 over x to the 5th, we wouldn't get
Right.
okay.
But I mean, here's the thing. You might be saying, "Oh gosh, I can't believe that." Okay. So in the first place, I promise you, I'm not misleading you. Okay. that is exactly what will happen. And I'm also telling you that this is one exercise. You're going to need to do it this way. Not like all semester. It's just this one. So part of the reason is just to make sure that each of you individually can do this. Relatively straightforward task. But you've got to also understand that it's my job to service everyone who's in the course, and I can completely appreciate if this is if you're already completely comfortable with this. But believe it or not, there's a good number who aren't. So I have to find out who is not comfortable right now. Like, I wish I already knew, because then I could help those folks. But the best I can do is ask right now, and that's what I'm doing. Yes?
So it'll be one of the written exercises?
Yeah.
And will it say on like the top?
Yeah, it'll be very clear. So do it. It'll say something like evaluate the following expression in exponents by reducing it to repeated multiplication. So it'll be completely clear. Okay, please don't think that we're going to be doing this, forever. All right. Last one we have time for today is how about this one? So this is like Exponent Law Number 4 or something. Exponent. So now I need two reals. So let x and y be in the reals, and just one exponent now in the naturals. And now we want to do this. So suppose we have a group x multiply y like that, and then we're going to raise that group to exponent n. And I'll leave myself a blank there. And we want to figure out what should it be. Okay? So how about, 3 times, let's mix it up. Let's put an a. That sounds great. And then we'll make it a 4 there. And all we can do is just follow the only rules that we know. So that 4 exponent means that whatever it is that is in that group, it needs to be replicated 4 times. And then all those replicated factors need to be multiplied. So this is saying 3a multiply 3a multiply 3a multiply 3a. Okay, so I made 4 copies and multiplied them all together. Okay, now using the associative property, I can change this to 3a times 3a times 3a times 3a. So just the same thing, but without parentheses. And here's the deal. Like you can see, we've got a bunch of a's there and a bunch of 3's. And the thing that we really need is we need them to be close to each other. Right now they're interleaved. We need them to be close. So here's what I'm going to do. I'm going to take that 3 and leave it there, but I'm going to move that 3 and switch its position with that a, so that the new expression looks like this. So all that I did was I moved them like this. So that one went there, that one there, 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 there. But right near at the beginning, I did this. I put that a over there, and that 3 went there. So you see, I switched the position of those two. Now, is that a legitimate thing to have done? Okay, I agree with yes. But now I need you to invoke the magic word, the math statute that says that this is okay. So what's the reason why this is okay? Not associative. Associative is the parentheses thing. It's not the D one. Starts with C. That's the one. Commutative. So this is the commutative property. And again, this is something you need to know by name. Commutative property of multiplication. And again, the word commute is not chosen arbitrarily. Okay? To commute means to move. That's what that means. So like commuting students are students that don't live here. They live elsewhere and then they drive here. They commute. Okay, so to finish this up, I think you can imagine we could commute all the 3's to the front and all the a's to the back. And then represent it like so. Okay, so then would anyone care to speculate? What's the formula? Very good. X to n multiplied by y to n. Because that's like asking, if Sally has 10 bags and all of them have 1 apple and 1 orange, then how many apples? 10. How many oranges? 10. Very good. Have a nice Wednesday.